Our night sky is changing right now, and in a few decades, if not years, it will no longer be the same. Experts like Neil deGrasse Tyson have confirmed that Polaris is on the verge of exploding, prompting astronomers all across the world to sound the alarm. It has a terrifying backstory. Its unique status as the North Star is defined by its center location in the night sky. Up until this point, astronomers, navigators, and stargazers could always rely on Polaris. Our night sky and astronomical measurements might never be the same again if this changes in the near future. Come along with us as we reveal the seriousness of this threat and its implications for all of us. As Polaris draws to a close, let's examine its story. For millennia, astronomers and navigators have regarded Polaris as the guiding North Star, and it continues to be so today. Its constant presence in the night sky has been essential to navigation, which uses the night sky as a trustworthy point of reference. But all of this might alter in an instant. The future of this heavenly star is uncertain due to a new research article that was given by the prestigious Royal Astronomical Society in September 2023. The star is about to blow up and vanish from the night sky forever. Let's examine the star in question before delving into the ramifications of this discovery. Because of its closeness to the celestial North Pole, Polaris, sometimes referred to as the North Star or Pole Star, occupies a unique position in the sky. It appears to be almost motionless in the northern sky because it is situated almost exactly above the Earth's North Pole. It is situated in the Ursa Minor constellation, sometimes referred to as the Little Bear or the Little Dipper. In terms of size, Polaris is a yellow-white supergiant star that is quite bright and significantly larger than our Sun, albeit it is obviously much farther away. It is thought to have a radius roughly 40 times that of the Sun. Although Polaris is part of a complicated triple-star system, it is frequently mistaken for a single star. With a third companion, Polaris B, orbiting the binary pair, the primary stars Polaris AA and Polaris AB appear as a single star to the unaided eye. These stars' interactions with one another produce a gravitational pull that shapes their orbits and affects how each behaves. The luminosity and properties of the stars involved are likewise impacted by these complex dynamics. Unusual changes in the star's brightness or pulsation patterns may result from any disruptions in these interactions. The precise workings and complexities of these relationships are still unknown, though. We do know that it takes about 323 years for light from Polaris to reach Earth, because it is located about 323 light-years away. This indicates that the light from Polaris that we see now is the same as it was 323 years ago. Because of the distance, we wouldn't be aware of Polaris' explosion until 323 years from now if it happened today. The event would have happened more than 3 centuries ago by the time we saw it from Earth. Scientists' forecasts, of course, are based on the empirical facts that we now have, which means that Polaris may have already burst, and we haven't yet seen the results of that event. The North Star has historically been important for navigation, culture, and symbolism in many different cultures and periods. Ancient mariners and tourists found it to be a very useful navigational tool, because to its stability and permanent position close to the celestial North Pole, sailors were able to navigate across countries and oceans by using it as a guiding beacon. Particularly in the Northern Hemisphere, it served as a trustworthy reference point for establishing direction because its position was almost exactly in line with the Earth's axis. Polaris is a culturally significant symbol. In many cultures, it was seen as a pole star that had stayed still in the middle of the night sky's celestial dance, signifying stability and tenacity. It frequently represented direction, steadiness, or a heavenly anchor in tales and folklore. For astronomers, Polaris was also essential because of its unchanging position in the night sky. It aided in the study of the motions and patterns of the night sky by acting as a reference for monitoring other celestial bodies. We were able to learn significant things about the nature of variable stars and stellar attributes because Polaris, a Cepheid variable star, exhibits periodic brightness variations. It was also essential for calibrating instruments and calculating cosmic distances because of this feature. We can easily predict the pattern, since these pulsations follow a predictable pattern, at least when the star behaves normally. The star has, however, recently departed from this typical practice. Astronomers have been perplexed by this disturbing abnormality in its pulsation cycle, which has led to a closer investigation of this cosmic enigma. Polaris has started to show an irregular and unpredictable cycle of dimming and brightening, rather than a regular pulsing pattern. The problem has now prompted scientists to express concern, claiming that the star might be nearing the end of its life. This fits with a pattern of actions seen when a star gets closer to the end of its existence. The interactions between the star system that we see as a whole are responsible for the progressive elongation of Polaris's pulsation period, which was historically steady in its periodic dimming and brightening. We can see that the pulse duration has increased by 4.5 seconds annually. Even though it might not seem like much, this is significant. According to some astronomers' conservative deductions, these variations in Polaris's atmospheric conditions may have been caused by the gravitational interaction between the stars, which would have had a direct effect on the pulsation patterns of the planet. Others, though, are not persuaded. Given that Polaris's mysterious behavior is strikingly similar to that of Betelgeuse, a famous star in the constellation of Orion, they assume the star may explode soon, and there is cause to suspect this. There have been mysterious fluctuations in Betelgeuse's brightness, raising the possibility of an impending explosion. Numerous analysts have already expressed concern over the star's impending demise. There are fascinating similarities between the activities of the two stars because of the mirrored variations in their patterns and brightness. Before they approach the end of their life cycles, supergiant stars in their twilight stages exhibit several behavioral traits. Despite pulsing constantly for eons, these celestial bodies experience odd variations in luminance as their stellar journeys come to a conclusion. The oddities that Betelgeuse displayed captured NASA's interest. In contrast to the anomalies in Polaris, the CIA is more concerned about the possibility of Betelgeuse exploding. NASA has shown a great deal of curiosity and concern about Betelgeuse's peculiar behavior, but Polaris has not yet received the same level of attention or concern. A journey through several stages of their evolutionary cycle is undertaken by seed stars. The brightness and temperature of newborn stars are comparatively low. After then, they enter the main sequence phase, which is characterized by nuclear fusion, and stay there for billions of years. They eventually enter the red giant phase, which is marked by a sharp rise in warmth and brightness when their hydrogen fuel runs out. Before a devastating explosion, the red giant phase experiences a sharp increase in energy output. A supernova is a brilliant exhibition in which they lose their outer layers. A white dwarf is the compact, dense core that is left over after an explosion. Scientists have concluded that Polaris has entered the stages of helium depletion, which are seen in seed stars toward the end of their life cycles. Based on the star's regular pulsations, a seed star experiences unpredictable pulsations that result in variations in brightness as it uses up its steady supply of helium. The erratic light emissions that result from this depletion may be a reflection of the depletion process taking place inside Polaris. However, it should be noted that although these anomalies are consistent with the characteristics of twilight phase seed stars, clear evidence of Polaris approaching the final stage of its life cycle is still pending. In an effort to comprehend Polaris's upcoming phase, astronomers are still examining and interpreting these anomalies. A supernova explosion from Polaris would probably be a breathtaking sight in our sky. Abruptly, the star would become so bright that it may surpass the moon and rank among the brightest things in the night sky. Days, weeks, or months may pass during this time. The star may undergo a significant transformation in appearance. It might change into a dazzling point of light or a fleeting item, sometimes taking on several colors before disappearing. Given that Polaris is currently the North Star and a component of the Big Dipper and Ursa Minor constellations, the visual display may momentarily change our view of these familiar patterns. You can be confident that we would be completely safe. Even if Polaris were to visually burst, the Earth would probably be safe because to its bulk and distance. Even if a Polaris explosion could not be as spectacular as Betelgeuse's, it might still be long, lasting and outshine neighboring stars. The scientific community and stargazers around the world would be fascinated by the phenomena, and astronomers and observatories would undoubtedly take notice. However, compared to a nearby supernova, the precise visibility and effect on Earth's atmosphere or environs would be less important. However, what about the actual star? What will happen to Polaris after it is on the brink of a possible supernova event? Let's be clear, Polaris is unlikely to die by supernova, whereas massive stars typically do so. Typically, a tremendous explosion takes place inside a large star when it goes supernova. This event, which is the last catastrophic phase of that star's life, causes heavy materials to disperse and occasionally results in the production of black holes or neutron stars. The star's core completely collapses throughout this phase, and then it explodes with energy. But if Polaris took this path, its relatively lesser mass might have a distinct effect on its metamorphosis. Given its size and intrinsic characteristics, Polaris may have a less spectacular demise and turn into a white dwarf, a dense, compact remnant. The leftover core of a star that has stopped nuclear fusion and shed its outer layers is known as a white dwarf. For stars that aren't large enough to explode as supernovae, it is the last stage of evolution. Polaris's life cycle would come to an end when it turned into a white dwarf, leaving behind a thick, gloomy residue that would cool over billions of years. The exact result will depend on the star's mass and internal makeup, which will determine how it eventually changes from a supergiant to a white dwarf. In any case, astronomers and observers would suffer a great loss if it disappeared, necessitating a rethink of how we perceive the night sky and celestial navigation. In order to navigate, scientists will need to locate a different reference star and adjust their knowledge of cosmic distances, measures, and the celestial coordinate system. Ultimately, Polaris's cosmic story serves as a moving reminder of how dynamic the universe is. The scientific community is on guard as we await the star's last act, ready to observe and record the possible celestial display that may take place in the sky. As we say goodbye to a guiding light that has brightened our nights for decades, it will be a celestial event to see, if and when the time comes.